Hi all. Here we're going to take a look at a few examples of how to convert angles from degree to radian measure. 1 radian is an arc on a circle of the length equal to radius. So 180 degrees is equivalent or equal to pi radians. Those are two different representations of the same value. Notice that arc length of AC, which is half of the circle, divided by a radius is equal to 3.14, which is rounded off value of pi. So if I have an angle COA and I measure it in degrees, it will be equal to 180 degrees, and if I measure it in radians, it would be pi radians. Now, I'm going somewhere with this. Let's say I have 5 and I divide it by itself. The result will be equal to 1. Or let's say we have 7 inches divided by 7 inches. Inches would cancel. 7 would go into 7 one whole time. So a quantity divided by itself is equal to 1. Let's say I have 13 grams of something and I multiply it by 1, I will still have 13 grams. Where I'm going with this is that if I take measure of angle COA that I have calculated in degrees, which would be 180 degrees, and I divide it by measure of angle COA, which would be pi radians, we have established that quantity divided by itself is equal to 1. Where I'm going with this is that angle measurements of 180 degrees to pi radians, the ratio is always 1 because it's the same angle divided by itself. So I can set up proportion of 180 degrees to pi radians or pi radians to 180 degrees, and this value is equal to 1. I can use it to multiply any other angle in order to convert it between radians and degrees. And the reason I can freely multiply by this sort of fraction is because it's a quantity divided by itself and it's equal to 1. And multiplying by 1 preserves the original amount. Let's practice. Here we have to convert the angle from degrees to radians and reduce the fraction. So we have 230 degrees. We want to cancel out degrees, so I would put 180 degrees in denominator and pi radians in numerator. We are multiplying a whole number by a fraction, so 230 degrees is out of 1. Multiply numerators, we're going to have 230 degrees times pi radians. Multiply denominators, 1 times 180 is 180 degrees. And let's reduce. Degrees divided by degrees cancel out. 230 and 180 both end in a 0, so I know I can divide both of them by 10. So let's reduce top and bottom by 10. 230 divided by 10, we get 23 pi radians. Out of 180 divided by 10, we have 18. We can represent this as 23 out of 18, the fraction times pi radians. Let's convert 160 degrees into radians. The fraction is still the same. We want to have radians, so we multiply it by pi radians. And in order to preserve the value, it has to be out of 180 degrees, because this way it's equal to 1. 160 is a whole number, so it's out of 1. So we get 160 degrees pi radians out of 180 degrees. We still need to reduce the fractions. Now degrees and degrees will cancel. We can reduce 160 and 180 by 10 since both of them end with a 0. So now we have 16 pi radians out of 18. 16 and 18 are both even numbers, so I can reduce both of them by 2. So we get 8 out of 9 pi or pi radians. Negative 330 degrees. We are still converting from degrees to radians, so I'm going to put 180 degrees in the denominator because this is what I need to cancel out degrees with degrees. So pi radians will go in numerator. 330 degrees is a whole number, so it's out of 1. We are multiplying numerators and denominators together. So we get negative 330 degrees pi radians out of 180 degrees. We know we can divide 330 and 180 by 10 just by looking and seeing 0 at the end. But here's a test for divisibility by 3. So let's see. 3 plus 3 plus 0. It's 6. I can divide 6 by 3, so I can divide 330 by 3. 1 plus 8 plus 0 is equal to 9. I can divide 9 by 3, so I can divide 180 by 3. If you can divide two numbers by 10 and 3 at the same time, you can also divide those two numbers by the product of 3 and 10, which is 30. So I'm going to cancel out degrees, and I'm going to divide numerator by 30 and denominator by 30. That's a shortcut, but you can always reduce by 10 and then reduce by 3 as a second step. As a result, we will have negative 330 divided by 30 is equal to 11 pi radians, or just pi, out of 180 divided by 30 is 6. Here we have to convert negative 150 degrees into radians. So let's multiply by the same fraction of pi radians out of 180 degrees. 150 is out of 1, so we have negative 150 degrees pi radians out of 180 degrees. Top and bottom can be divided by 10. 1 plus 5 plus 0, that's a 6. Yes, I can divide 150 by 3. 1 plus 8 plus 0, that's a 9. Yes, you can divide denominator by 3. So we can divide by 3 and 10 at the same time. Thus, we can divide by 30 at the same time. Negative 150 divided by 30 gives us negative 5 out of 180 divided by 30 is 6, and we still have pi radians, or just pi. Here we have to convert negative 270 degrees into radians. Procedure is still the same. We multiply by pi radians out of 180 degrees. 270 is out of 1, so we get negative 270 pi radians out of 180 degrees. Degrees and degrees will cancel. We can reduce top and bottom by 10, and we get negative 27 pi radians out of 18. We can also divide 9 into 27 and 18 at the same time, and we get negative 3 out of 2 pi, or pi radians. Here we have to convert 135 degrees into radians. Ratio is still the same, pi radians out of 180 degrees. 135 is out of 1. Multiply numerators and we get 135 degrees times pi radians out of 180 degrees. Degrees and degrees will cancel. 135 ends in a 5, 180 ends in a 0. Both of them can be reduced by 5. We get 27 pi radians out of 36, and I can see that both of them can be divided by 9. So divided by 9, and we get 3 out of 4 pi, or pi radians. That's all.